Hi, and welcome to the YouTube channel where you'll see a completely different kind of AutoCAD than what you're used to. No more slow repetitive methods. Here we take the things to the next level. I'll show you how powerful AutoCAD becomes when you combine dynamic blocks with Lisp, and the results are pure wow. In today's episode, we dive straight into the core of a column reinforcement, but not the old slow way. We are leaving behind the repetitive methods and stepping into the next level: smart dynamic blocks, Lisp automations, and the workflow that turns hours of work into minutes. We're going to build a reinforcement of a column step by step, but with a twist. The blocks adapt themselves, the dimensions update instantly, the Lisp handle the calculations for you, and you're only left with the creative and technical decisions. So, if you've ever worked in AutoCAD and felt like you're wasting time on the same repetitive operations, this episode will change the way you work forever. So, how you can generate stirrups, longitudinal bars, dimensions, and labels with mathematical precision without dragging lines and offsets ever again. Okay, so what you see now is the final form of the column, and we're going to recreate it with the methods I mentioned. So, we suppose we have the levels, architectural levels of the building, and we're going to construct from scratch starting from these levels. It's a 3-story height building. So I'm bringing a block that represents an elevation of a column suitable for a 3-story. From the parameters, we can adjust the cross section of the column by applying values, 60s on 60 centimeters, and each level will have a height of 4.5 meters. The beams will have 60 centimeters in height on each level, and the foundation, let's say 80 centimeters in depth. Okay, we don't need these levels anymore. Now we're going to put some cross sections with the perimetral and vertical stirrups. They are going to build themselves right now, as you can see. The Lisp is computing the adjustments of the stirrups. It takes a while, longer than usual. And now we're going to change the diameter. We're going to choose two kinds of stirrups, a 12 and a 10 millimeter. Okay, and we choose to have on all levels the intermediate vertical one with a width of 25 centimeters. And it adjusted. Now we're going to put on the same elevation another set of stirrups, horizontal ones this time. They're building themselves on the elevation. We're gonna choose for them as well a 10 millimeter diameter. And again, we want them on each level to be over 25 centimeters width. Alright, now we're going to apply on each level the cross section of the reinforcement. So we have on each corner of the stirrup a different set of rebars in their cross section, right? So for the first level, we're going to choose a 25 millimeter with 20 millimeter. For the next level, we're going to choose, let's say, a 22 with the same 20. And for the last level, in the corners we're going to choose 20, and let's say on the sides a 16 millimeter. Now we're going to break these, explode them, don't worry. Inside there were nested blocks representing each diameter, and we're going to apply for each level the whole set of diameters at the base of each level. And as you can see, it brings a basic form of rebars, cranked ones for diameters higher than 20 millimeters, and if it's 16, it's a straight bar. Now we're going to make some adjustments, and we're going to transform these into L bars, L-shaped bars. Okay, we're going to twist them. We're going to extend them to the level, and we're going to give them a concrete coverage at the top of 5 centimeters. Okay, the next ones are going to be overlapped. So we make a small arrangement here, and now we're going to choose bar by rebar and simply overlap them with a special command, of course. It chooses the minimal diameter between the two, okay? Again, small adjustments. We can dimension this overlapping. Again with a special command, and we can equalize these values, meaning we are going to bring the crank on the top of the other bar. And we're going to do that parametrically. Small adjustments. And now we have the rebars fully armed on the elevation. We're going to regenerate, and the length of rebars will be adjusted, as well as the number of the stirrups on each level of the column. Now we want to take these rebars and place them on the body of concrete, if not for other things, at least for visual reasons, let's say. So we make the assumption we're going to watch the column on each level from the bottom of the section upwards, and basically we're going to see only this set of rebars on the elevation. So we're going to choose sets of rebars according to the diameter. We're going to start with the 25. We associate it to the 25 and we place it here. Again, we take the 20, associate it with 20, and we place it here, meaning at the base of each level. So we can take these two now and flip them manually. All right, so we continue with the same command. I'm choosing the 22 millimeter and again the 20. Again with the flip, and the last level, the 20 associated with the 20 at the bottom of the level, and finally the 16 cross section with the 16 at the bottom of the level, and the last flip. And look, now we have, in a matter of 1-2 minutes, a fully reinforced column on the elevation and on the cross section. We apply another regen to make sure all the data is fresh. And for the next step, I'm going to apply on the sections the label, the tags of the longitudinal bars. So for this part of the exercise, I'm going to copy and bring these bars closer to the sections, because I don't want to make a lot of zoom and pans on the screen. It's easier that way. We're going to discard these later. We are just going to need them now for this part of the work. And again, we apply the command suitable for tagging, and we're choosing sets of the same diameter associated with the same diameter. And as you see, it brought the tags of this rebar. Now we can make some small adjustments, spread them a little bit, and continue. Now we're choosing this set with this set on the horizontal sides. Okay, and again this set with this set on the vertical sides. And by region, we can see the data is refreshed. Of course, we can make some very small adjustments. We can discard these ones, and I will continue fast on the next levels. Spread them a little bit, and again the upper and lower sets and the left and right sets. Again, with a region, and finally the last level. One set, second set, again small adjustment, and the final bars. And on the other side. Okay, I'm going to retake the command, discard them, regen, and we have now a fully reinforced concrete column. Of course, we can make small adjustments. Let's say on the vertical ones, we can choose all the levels, and we're going to apply this parameter. As you can see, it shifts one of the vertical stirrups, and we're doing this only for graphical purposes only. It basically shows how the reinforcement cage comprised of these stirrups is made if it wasn't clear enough from the section. And there it is. There it is. Now we can open the layer of the rebar marks. Don't worry, the rebar marks will be explained in a future episode. For the time being, all you need to know is that this rebar mark of let's say 22mm rebar is completely associated to the bar in elevation. And I'm going to demonstrate how we can actually put numbers to these marks from 1 to whatever it takes. So we can actually explode at the end all the blocks and prepare the drawing for the final plotting. I'm breaking it. I'm using a command that will kill all the fields in the drawing at once. Okay. So now I can apply a command that is called the mark on the entire drawing, meaning the element. And you will witness here the transformation. As you can see, the stirrups have marks 1 and 2, and then the bars 3, 4, 5, 6, and so on. And they are fully correlated on the sections, on each level. Of course, we can make the reinforcement schedule, but this will be a topic for a next episode as well. I just wanted to show you how fast and precise, with a normal workflow, we can actually build a reinforcement for a concrete column from scratch. How fast and precise. I bet you cannot do that in Allplan, in Tekla, in Revit, in a matter of minutes. Okay, so if you liked what you saw, if it grabbed your attention and made you curious, stick around, because this channel is where all the real secrets drop. So in the next episodes, I'll break down step by step the exact process you just watched. Don't forget to hit a follow, smash that like button, and share it with someone who needs it. Until next time, stay sharp and take care.